I have started recording, but it's I don't know whether it's yes, it is. Okay. Okay, let me share the slides and then we'll continue. Okay जी, can you see the slides? नजर आ रही हैं slides आपको? I hope आप सबको नजर आ रही होंगी.
Yes, sir.
Okay. So let's quickly overview what we have done last time, because this topic is related, very much related to what the last discussion which we have done. It's 3 point. It's basically principles of reliable data transfer. So just to give you an idea that basically if you look at this side, right side, that we have unreliable channel. We are assuming that channel is unreliable and we want to implement reliability over unreliable channel. So this is the sender side and this is the right side is the receiver side. Right, Ji? Right side is receiver side. Okay. Now basically you can see here that we want to implement reliable data transfer at transport layer. Okay, this is a so we'll be implementing reliability at this transport sender side as well as on receiver side. This is sender side and this is the receiver side. So basically what we want, the complexity of this reliable data transfer protocol depends on the characteristics of an unreliable channel. Let's say that your unreliable channel loses data as well as corrupting the data as well as reordering the data. So the complexity of that protocol would be high in comparison to a channel, suppose that only lose data or that only corrupt data. So therefore, as you increase the characteristics of unreliable channel, complexity becomes high. So this is something which is there. So second thing we have discussed last time, that sender and receiver do not know any state of each other, right? So this is a kind of curtain that they don't know the state of each other. So I'm going quick because we have done this thing in last time. So I'm just reviewing it quickly. So this is a sender side implementation of a protocol on a sender side, and this is a receiver side implementation. So we will be using basically 4 processes. So RDT send, whenever the data is available from upper layer, so RDT send will be called, and that data is passed to from upper layer to transport layer. And UDT send means that called by RDT to transfer packet over that unreliable channel. These two processes are at the sender side. The other two processes, RDT receive and RDT deliver data, are at the receiver side. RDT receive gets that data from channel and basically process it, packet on the receiver side, and the delivered data basically called by RDT to deliver data to the upper layer. So these are the 4 processes which we are going to use then. Or actually it's a bi-directional communication over unreliable channel. So you can assume that these 4 processes are present at sender as well as at receiver. क्योंकि अगर bi-directional होगी तो दोनों साइड पे सारे प्रोसेस मौजूद होना जरूरी हैं. But here we will be considering unidirectional, but same concepts can be extended for bi-directional transfer of data. This is the data, and we are assuming a data at the upper layer, that is application layer, and basically transport layer or RDT basically gets that data and add a header, and we call this as a packet. So these are the terminologies which we are going to use, and then that packet will be transmitted on a unreliable channel. So again, last time we said we will incrementally develop sender receiver side of RDT protocol. So we will be considering unidirectional. We will be using state machines. So this is event over action. Whenever we are moving from one state to next state, there will be an event, and on the occurrence of that event divided by actions. So what actions can be taken? So this is a terminology which we are going to use. Last time we studied the RDT version 1, RDT 1.0 or 1.0, and basically it's a kind of ideal protocol that we are assuming that our underlying channel is perfectly reliable, which is not true. This is an ideal thing, but again, to start with, we are assuming that there are no bit errors, there is no loss of packets. So it's perfectly reliable. So in case of that, we are going to have a FSMs, separate FSMs for sender as well as at receiver side. So this is a sender side. So RDT send data will be called whenever data is available from received from upper layer, and then event. This is the event which occurred, and action is to make a packet of that, and UDT send will be called to send the packet to the channel. And after doing this, event divided by action, it will go back again to this state, wait for call from above. This is the sender side, receiver side would be opposite to each other. When packet is received, event is a received packet from reliable channel, and then extract that packet and then deliver it to the upper layer, and then again this. So this is quite easy in this context, right? So if you have any question regarding it, because now we are going to start from here, basically we will be dropping these ideal conditions one by one in next version of RDT. So therefore, if you have any questions so far, you are welcome to ask. Is it okay to everyone, Ji? Is it okay to everyone? किसी को कोई question है तो welcome. Okay, I assume. Can you hear me, Ji? Am I audible to everyone?
Yes, sir.
Okay. Okay, Ji. So next slide. Let's move to the next slide if you don't have any questions. So from here onwards, we'll start today. So now we are going to have a next version of RDT, and we are calling it as RDT 2.0. Remember that in RDT 1.0, we said that the channel is not making any errors and no loss of packets. Now we are saying that we are dropping one condition only, one ideal condition only, and recall that ideal condition was that no bit errors. Now we are dropping this, and look at this, my cursor, no bit errors. Now we are in RDT2, we are dropping this condition, and we are saying that underlying channel may make errors. So making error means it may flip bits in the packet, right? Now, how to handle this? The answer is checksum. Recall checksum you studied. So we can use checksum to detect bit errors. Okay, at the receiver side, we can use a checksum. At sender side, you know the process checksum. But the question is how to recover from errors. How to recover from errors. Checksum only tells you that your packet has error or no error. It does not tell you the location of bits. So how to recover from errors? So this is something which is there. So the question is, how do humans recover from errors during conversation? कैसे करते हैं humans? Can anybody tell me? Okay, when you are talking to your friend or anyone else, and you did not understand something, or you understand wrongly something, so what will you do?
सर हम कहते हैं कि प्लीज रिपीट जो भी आपने बोला अभी.
जी, उसको क्या कहेंगे?
सर
कि रिपीट करें
ना
आप.
समझ आए तो रिपीट करने का कह देंगे, या फिर उसके वैसे कह देंगे कि यानी कि हमें समझ नहीं आई कि आप यानी कि बोल क्या रहे हैं.
तो रिपीट करने का कहेंगे बेसिकली. ठीक है ना, उसको कहेंगे कि दोबारा बात करे, वही बात दोबारा करे. ऐसे ही है ना. इट मीन्स रिपीट करने का मतलब ये है कि वट एवर ही सेड अर्लियर, he has to you know again say the same thing. ऐसे ही है. So whatever he has sent to your ears, and he has to say the same thing again, and assuming that this time there will be no error. Okay. Okay. Anyways, now let's move to our RDT with bit errors. So let's start with this. So as I told you earlier that our underlying channel may flip bits in packets. So in order to handle this, we can use check bit to detect errors. So again, the same question during conversation, which we have said that now we are going to find out that how to recover from those errors. So in order to do that, we will be using one, from receiver to sender, a special packet, call it as special packet, known as acknowledgements. We are calling it as acknowledgements, X. We are abbreviating it as X. So what receiver will do, that receiver will explicitly tell sender by sending these packets, special packets. Now I'll not call it as special packet, just for understanding, for your purpose I said special packet. So basically why is, because it's a chunk of bits. So but again, whenever a sender sends something to the receiver and receiver receives that packet correctly, then in response to that, receiver will explicitly tells the sender that packet received is okay, and that is being done with the help of acknowledgements X. So it's a kind of feedback. It's a kind of feedback. You can think like as a feedback that the receiver will send explicitly X to acknowledge that your received packet is free from any errors. Okay, so X will be used. So naturally, there are two possibilities. There may be no error and there may be error, right? So in case that if there is an error, receiver will send another type of packet, special packet, which is known as NAC, negative acknowledgements, NACs. And next will tell the sender that packet had errors. So these are the two new things which we are going to use to detect the to get handle the bit errors during communication. So X and next will be transmitted to recover from errors. Now you may be wondering कि okay, sender को पता लग गया कि whether the packet it has sent is received okay or not, but how to recover from errors? Still this is question is pending. So answer to this is that sender will retransmit the packet on receipt of NAC. Like you repeat, during conversation, you repeat whatever you said. The same thing is here, that sender will retransmit packet on the receipt of NAC. So this would be done, right? So these are the three things which will be used to recover from error. So this phenomena is known as stop and wait. Why we are calling it as stop and wait? Because sender sends one packet and then waits for ACK or NACK. And once it gets ACK or NACK, then it will proceed further. Otherwise, it will not proceed. So that by virtue of this property, we are calling it as stop and wait phenomena. That sender is sending a packet and then it is waiting for ACK or NACK. If ACK is received, then it will send the next packet. If NACK is received, it will retransmit the packet. Please have a look on it. I'll give you around 30 seconds to or 1 minute.
पॉसिबिलिटी है कि जो दोबारा रीट्रांसमिट हो रहा है वो उस पे भी एरर हो.
फिर नैक आएगी, फिर नैक भेजेगा रिसीवर. बेटा इसमें एक चीज है, बिट्स एरर क्यों आती है? नॉइज की वजह से. चैनल में नॉइज होती है, इंटरफेरेंस होती है, ठीक है. देयर इज अ इंटरफेरेंस और नॉइज. ओके, so that's why bits are flipped. Now this interference is random in nature. I mean, आप अगर आपको पता लग जाए कि चैनल में इस पॉइंट पे हमेशा आएगी इंटरफेरेंस आएगी, तो आप उसका सोल्यूशन फाइंड आउट कर सकते हैं, आपको परमानेंट सोल्यूशन लगा सकते हैं उस जगह पे. लेकिन रैंडम नॉइज इंटरफेरेंस जो है रैंडम होती है, किसी वक्त भी आ सकती है और किसी टाइम पे आई मीन वन प्रेडिक्ट कि किस वक्त किस वजह से आएगी. वन थिंग. So therefore it is possible कि फर्स्ट ट्रांसमिशन में नॉइज इंटरफेरेंस आई और बिट फ्लिप्स होगी, लेकिन जब रीट्रांसमिट किया तो ना हुई. एंड इट इज आल्सो क्वाइट पॉसिबल कि सेकंड टाइम भी होगी, थर्ड टाइम भी होगी, फोर्थ. सो देयर इज अ थ्रेशोल्ड कि अगर आपकी लेट्स से कि अब इट डिपेंड अपॉन द स्टैंडर्ड कि लेट्स से वो 10 टाइम्स या 15 टाइम्स तक नहीं होती, तो इट विल सेंड अ एरर मैसेज के सेंडर इज अनरीचेबल और रिसीवर इज अनरीचेबल, लाइक दैट. ठीक है. Is it okay जी इर्तजा?
यस सर, मतलब ये अनप्रडिक्टेबल है ना, मे भी अगली
जी
दफ़ा नॉइज ऐड ना हो तो हमें रीट्रांसमिट सही हो जाए और एरर ना हो उसमें।
जी बिल्कुल ऐसे ऐसे, यानी ये रैंडम इन नेचर है, नॉइज इज रैंडम। Okay, Ji, I assume you have understood this. So now let's proceed further. This is slide number 11. I will move to next slide. So now we'll talk about FSM. That what would be FSM? Recall now, in order to understand this FSM, you need to understand the FSM of RDT 1.0. That was a simple one. It was only sender side. If you recall, it was only waiting for a call from above. There was no concept of ACK because underlying channel was reliable channel. But here we are saying that underlying channel is unreliable, and it is only, we are assuming it is making bit errors. So now we have two states. In order to cope up with this, sender side has two states is in comparison to RDT 1.0. In RDT 2, you are seeing here wait for call from above, and then there is other state is wait for ACK or NAC. Now, so what will happen? So look at this event RDT send is called when data is available from upper layer and data, this event has occurred, that data is available and data is given to transport layer or reliable, the transport layer, let's call it as transport layer. Now we are calling it as that what transport layer will do, or RDT2 which is present in transport layer, what it will do, it will make packet now data, and now look at this change checksum. It will calculate the checksum also. It will calculate the checksum in make packet में data के साथ साथ अब checksum भी होगा. This is an additional thing. And then after making this packet, it will send the data by using UDT send process to the channel, right? And after doing this event divided by action slash actions, it will move to next state, and this state is wait for ACK or NAC. So after doing this, stop and wait, right? So after sending this packet to the channel, it will move to state of ACK or NAC, wait for ACK or NAC. Okay, ji. Then what will happen? So then now there are two possibilities, right? ACK can come or NAC can come. So suppose that we have received a packet from receiver side, RDT receive. Now this receive will be used RDT receive packet, and this is a ACK packet. This is a ACK packet. The packet received packet is ACK. So this hat sign means no action. Even no action will be taken. If it is a hat, this hat sign is basically indicating no action. No action is required. Event is this, that packet is received, and this is a ACK packet. So divided by no action, but it will move from ACK to NAC to wait for call from above, and then it will repeat. If there is a packet again from upper layer, so this process will be done and it will go again to ACK or NAC. Now there is one possibility is that you have got received the packet and that is ACK, but there is another possibility, right? But what is the other possibility?
सर
जी
उसमें एरर है, यानी नैक भेजा उसने।
ओके ओके नैक भेजा, तो इसको भी हमने हैंडल करना है, राइट? सो इन ऑर्डर टू हैंडल this is something that received packet and that is NAC. Now if it is NAC, then it will resend the already sent packet again. So UDT send action is again send the already sent packet again, retransmit the packet. UDT send packet, this packet send packet. So it will again send the earlier sent packet again, and then it will move again to the same state, wait for ACK or NAC above, right? So this is RDT2. This is RDT2. This completes discussion of center side of RDT 2.0. So if you have any question, you are welcome.
सर ये इज नैक तो रिसीवर साइड से आएगा ना, यानी
जी
वेट
रिसीवर
फॉर
से आएगा, बिल्कुल रिसीवर से आएगा, लेकिन सेंडर पे रिसीव होगा ना।
यस सर, यानी सर ये वेट फॉर एक और नेक नेक्स्ट स्टेट पे वब जाएगा जब हमारे पास रिसीवर साइड से कोई एक्नॉलेजमेंट आ जाए।
नहीं 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 बेटा, पैकेट भेजने के बाद सेंडर स्टेट पे चला जाएगा। ये मेरा मूवमेंट देखें, जब पैकेट उसने चेक सम बनाया और उसके बाद उसने चैनल पे भेज दिया, उसके बाद वो फौरन स्टेट पे जंप कर जाएगा। ये इवेंट और एक्शन कहाँ यूज होते हैं? ये रिकॉल इनिशियली कि हमने कहा था एक स्टेट से दूसरी स्टेट में जाने के लिए इवेंट और एक्शन होंगे, ठीक है ना। तो जब इसने पैकेट बना के चैनल पे भेज दिया तो उसके बाद फौरन ये जंप कर जाएगा। इट विल बी कम इन दिस स्टेट, वेट फॉर एक और नैक, इट विल बी वेटिंग, इट विल बी इन वेट ऑफ फॉर एक और नैक। कहां से आएगी एक और नैक? रिसीवर साइड से आएगी नेचुरली। सो ये पैकेट बनाने के फौरन बाद वो स्टेट में आ जाएगा, ट्रांसमिट करने के बाद चैनल पे। ओके जी।
ओके सर।
Okay, now let's look at receiver side. What is happening at receiver? This is a sender side. This FSM is for sender side. Now what is happening at receiver side? Let's have a look on it. So receiver is waiting for call from below. And what is below? Below क्या है? Below क्या है? Channel है? Is it like this? Channel ही होगा ना
यस सर।
नीचे। Okay. Now it has received, let's say event has occurred, it has received a packet and that is a corrupt packet, that bits are flipped in it. वो कैसे चेक करेगा? आपको पता है चेक सम वाला मेथड आपने पढ़ा है, उसके लेट्स से कि वो उससे चेक करता है और उसे पता लगता है कि पैकेट इज करप्ट, then it will send event this is packet is received and it checked and it is a corrupt packet. Then what it will do, it will using UDT send, it will send a NAC and it will again move back to the same state, wait for call from below. So NAC, it will send NAC if packet is corrupt, right? And there is another possibility, and the other possibility is ke packet is received and it is not corrupt, right? Received packet is not corrupt. So what it will do, it will extract the received packet and get the data from it, and using delivered data process it will send it to the upper layer. And after doing this, it will UDT, it will send an ACK to the sender. So UDT send will be used to send an ACK to the sender. So this is the event, and these are the set of actions which will be taken by receiver. And after doing this, it will again come back to the same state, wait for call from below. So this is a FSM of side. So if you have any question, you are welcome. Then I'll discuss one thing. One thing you need to understand is state of receiver, that the receiver state kg did not, what is that state kg, did the receiver get my message correctly or not correctly, isn't known to the sender unless somehow communication is done from receiver to sender, feedback. सेंडर को कोई पता नहीं है कि उसका जो पैकेट है वो करप्ट हुआ है या नॉट करप्ट है, अनलेस के रिसीवर फीडबैक या इन द फॉर्म ऑफ एक और नैक नहीं भेजता, तो उस वक्त तक रिसीवर सेंडर को नहीं पता लगेगा कि व्हाट इज द स्टेट एट द रिसीवर, कि वेदर स्टेट रिसीवर ये वाली ऊपर वाली है या नीचे वाली इवेंट एक्शंस में. So it means that's why we say we need a new protocol, we need a protocol that basically sends the feedback from receiver to sender. Have a look on it. If you have any question, you are welcome. So this is what we have, कि अगर वो फीडबैक नहीं आएगी तो ये दिस इज अ कर्टन, कि सेंडर को कुछ पता नहीं है क्या हुआ. So this is that how basically it gets this. Yellow highlighted देखें, ये neck से उसे पता लगा, neck receive हुई तो उसे पता लगा ये hidden है, तो उसको neck से पता लगेगा कि neck ने receive की तो उसे पता लगा कि जी पैकेट corrupt है, और अगर egg receive हुई है तो उसको पता लगेगा कि पैकेट यह received हो गया without errors. So have a look on it. अगर किसी को कोई क्वेश्चन है तो पूछ सकते हैं. Okay, Ji, is it okay to everyone?
Yes, sir.
Okay, let's now move further. Now let's look at the state operation with no errors, RD2 version working operation or working of RDT 2.0 with no errors. So this is a sender side. So this will happen at sender side, and these are FSM of sender side and this is the FSM of receiver side. So let's say that how it will work when there is no error. So look at this red colored. Okay, wait for call from above. Step 1, that sender is waiting for a call from above. Next step is that the receiver is waiting for call from below. So these are the initial states at the sender and receiver. Now we are considering operation with no errors. Okay, so look at this step by step approach to understand that how operation with no errors will work. So again, sender is waiting for call from above. Look at the red highlighted area, and this is the red highlighted area at the receiver. Now suppose that packet has come. Look at this highlighted area, red highlighted area, that RDT send data has come from upper layer. RDT send is used to get that data. Then as an packet is made and checksum is computed, and this packet is given to the channel using UDT send. So these are the sequence of event and actions were taken at the sender side. Okay. So this is transmitted. Look at the arrow, red arrow. Follow the error. Sorry, follow the arrow, red arrow. This is transmitted and to the channel, and sender has state has changed from wait for call from above to a state wait for ACK or NAC. So this is a state after sending the packet at the sender side, red state. And this is a channel, you can think like as a channel, and now suppose that this packet has been received So there are no errors. So we'll consider this event, RDT receive packet and not corrupt, right? So this is something which is done at the receiver because we are assuming there are no errors. So it will extract the packet, deliver it to the upper layer, and UDT send ACK will be sent to the sender. Okay, again, this will be happening at the receiver because we are saying there are no errors, and then this it's little bit fast, but again follow this, that basically this is being done. Okay, ACK is transmitted, and when ACK is received, sender will have this event receive packet, and ACK is received, so no action, and but it will move from this wait for ACK or next state to the next state, again wait for column above. So this will happen, right? And in case of operation with no errors. So these are the steps or sequence of steps which will be taken in case of RDT 2.0 when there is no errors. So if you have any question, welcome. Okay, जी, is it okay to everyone? हमारे CR साहब मौजूद हैं?
Yes, sir.
Okay, that's good. I just want to hear your voice. Okay. Anyways, let's move to the next scenario, which is corrupted packet scenario. So please, the same sender and receiver, I'll give you 2 minutes to think that how it will work. Then I will show you the animation. Then you can verify whatever you have thought in your minds is same as of shown scenario or not. So this is a scenario in which corrupted packet is received. Corrupted packet received at the receiver. So this is a scenario. So please think on it. Okay, what will happen? In the same way which I have shown you little while ago with no error scenario.
सर पहले भी करा होगा, मगर यहाँ पर जो वेट फॉर द एक्नॉलेज और नैक पर था, यहाँ से वेट फॉर द कॉल फ्रॉम अबव पे चला गया था। जब तक नैक
Okay.
नहीं जब तक नैक आता रहेगा तो इसी स्टेट में रहेगा, यानी वेट फॉर द एक और नैक पर।
Okay. Okay, Ji. So, okay, I'll show you the steps. So again, wait for call from above. This is wait for call from below. Then again, packet is sent. But this is now and corrupt packet. Okay. This is something which will happen, that the packet is corrupt. The packet is corrupt. That packet is sent. Sender has gone to wait for ACK or NACK state, but because we are assuming that corrupted packet, so this is event or actions at the receiver, right? So it will receive a packet and it is a corrupt packet, so it will not deliver it to the upper layer. It will send a NAC. Receiver will send a NAC, right? And when NAC is received, so these are the sequence of events at the sender side. Event is received packet and is NAC, so it will again send the packet and it will remain in the same state. It will remain in the same state. It will remain in the, these are the actions, event actions, and it will remain in the same state. So next time, assuming it will, assuming a packet is sent and assuming no error, not corrupt. So it will move to the next state. Okay, Ji, is it okay to everyone? If anyone want to ask a question, welcome. If anyone has any question regarding working of corrupted packet scenario, welcome. I'll move to. So assuming कि next time जो है वो no error है, तो it will move to this action receiver पे ये होगा और ACK भेजेगा और ACK जब जाएगी तो again it will move from call from above. So if you don't have any question, I'll move to the next slide. Now, question is this: ke RDT2, you have reviewed RDT2, you have understood RDT 2.0, but it has a one fatal flaw, one very fatal flaw. So what is that flaw? What is your opinion? Question is to all of you, what is that flaw? जी, anyone have any idea कि क्या flaw है इसमें? कोई बता सकते हैं क्या फ्लॉ है? इट्स वेरी लॉजिकल. एक फ्लॉ है RDT2 वर्जन में. एनीवन?
सर एक तो मुझे ये लगी है कि रिसीवर एक ही स्टेट में रहता है लेकिन
नहीं नहीं, ये एक स्टेट में रिसीवर की स्टेट है ही एक ना. रिसीवर ने नीचे से ही रिसीव करना है, इसमें कोई इश्यू तो नहीं है वो. एक और चीज है, बड़ा सीरियस सा है. अगर आप हिंट इज के थिंक विद रिसीवर पर्सपेक्टिव, रिसीवर पॉइंट ऑफ व्यू जरा सोचे कि रिसीवर पे हैं और आप कुछ बेचते हैं. अच्छा,
सर
हमने ये,
हो
जी
सकते हैं
जी, गो एड.
सर, एक और नेक अगर करप्ट हो जाए तो
यस, दिस इज अ फेटल फ्लॉ. दिस इज अ फेटल फ्लॉ. अभी तक हमने कहा कि हमारा पैकेट करप्ट हो रहा है, मगर हम ये एज्यूम करे बैठे हैं कि हमारी एक और नैक कभी भी करप्ट नहीं होगी, which is beyond the reality. I mean, same channel is used for sending packet as well as ACK or NAC. So ACK and NAC can also be corrupted. What to do then? So what happens if ACK or NAC corrupted? So sender doesn't know what happened at the receiver. So it simply just retransmit because क्योंकि पॉसिबिलिटी ये है कि अगर एक हुई तो वो डुप्लीकेट हो जाएगा। अगर सिंपली रीट्रांसमिट कर दे सेंडर तो अगर वो एक हुई करप्ट हुई तो इट विल बी अ डुप्लीकेट, पॉसिबल डुप्लीकेट, राइट? सो दिस इज अ fatal error and we have to find out the solution for it. We have to find out the solution for it. We cannot simply retransmit because it will be a possible duplicate. So naturally we have to handle the duplicates. If a sender retransmits current packet, if ACK or NAC is corrupted, then it will be a duplicate. It is possible that we have a duplicate packet. So solution to finding out whether the packet is duplicate or not is to add a new thing in a packet, and that is known as sequence number. So now we have to add a sequence number to each packet to let the sender and receiver know that whether it is a current packet or previous packet, to find out this thing. So there will be a sequence number in each packet. Now what receiver will do? Receiver will, if there is a duplicate packet, receiver will discard this duplicate packet. Receiver will discard this duplicate packet and it will deliver up, right? So stop and wait again. Sender sends one packet, then waits for receiver response. Is it okay to everyone, G? Is it okay to everyone? If anyone wants to ask a question, welcome.
सर इससे तो वो एक्नॉलेज और नेट का करप्टेड का रिजॉल्व नहीं होता सर इस
बेटा इसी तरह रिजॉल्व होगा, और कोई तरीका है तो मुझे बताएं। डुप्लीकेट एक और नैक, वो यही तो तरीका हम अडॉप्ट करेंगे कि जी अगर एक और नैक करप्ट होगी तो सेंडर जो है रीट्रांसमिट कर देगा। सेंडर एज्यूमिंग कि वो जो है वो पैकेट रिसीव नहीं हुआ, सेंडर एज्यूम कि पैकेट रिसीव नहीं हुआ। अगर एक नैक करप्ट होती है तो सेंडर विल एज्यूम कि पैकेट रिसीव नहीं हुआ, इट विल रीट्रांसमिट इट। अब पॉसिबिलिटी बहुत एग्जिस्ट करती है कि वो जो है पैकेट रिसीव हुआ है, सॉरी करेक्टली हुआ है या करप्ट हुआ है। तो अगर तो करेक्टली हुआ है तो ये डुप्लीकेट हो जाएगा, ठीक है? ओके तो अगर सोचिएगा आप कोई और सोल्यूशन अगर हुआ तो विल डिस्कस, ठीक है बेटा?
यस सर
एनीवन वांट टू आस्क एनी क्वेश्चन? वेलकम। Otherwise, now let's move to RDT 2.1. This is 2.1 is the RDT which is handling garbled ACKs और NACKs, वही corrupted ACKs और NACKs, ठीक है? अब हम इसको इनकॉर्पोरेट करेंगे। जो अभी हमने बात की है, आपको बताया है कि सीक्वेंस नंबर वाला चीज अब हम इसके अंदर इनकॉर्पोरेट करेंगे। Now, I hope now you are familiar with these states very much. So now the first question is, because it's a stop and wait protocol, it sends the one packet and then it waits for, sender sends a packet and then it waits for ACK or NACK, right? So the next question comes in our mind that how many bits we should use for sequence number? How many bits should we use for sequence number? We need to decide this thing. We need to decide this thing, that how many bits should we use for sequence number. G, anyone having any opinion? जी, any opinion, anyone having any opinion? जी बेटा, कोई बताएगा? एनीवन? इतना मुश्किल नहीं है। कितने बिट्स चाहिए? Now this is a plus side effects of online class that I don't know because you are not responding, so I don't know how
सर
many
ये
of
तो
you are
एक्नॉलेज ही करना है ना, या नेक करना है, 0 और 1 एक ही बिट चाहिए होगी आई थिंक।
good, very good. एक ही बिट चाहिए होगी, very good. So you are right क्योंकि it's a एक टाइम पे जो है बेसिकली ये एक ही पैकेट भेज रहा है, राइट? तो अगर एक वक्त में एक ही पैकेट भेज रहा है, स्टॉप एंड वेट है ना, सो बेसिकली so we need only one bit, we need only one bit. Okay, good. So this is a 0 1, so you are observing here 0 1 0, call 0, call 1. Okay, so let's have a look on it. Let's have a look at sequence of steps which will occur to handle garbled acts or NACs. Oh, look at this. Now I'll not repeat lot of things again. So I'll simply show RDT send data. Look at this. Change अब observe हो रही है. कहाँ पे change इसमें? पिछले अगर RDT 2.0 से कंपेयर करें तो कहाँ पे change आ रही है? तो ये I hope you have observed this. जीरो आ गया है, ऐसे ही है. ये पैकेट के बाद आप देखें जीरो आ गया, ये सीक्वेंस नंबर का जीरो है. डाटा चेक्स हम RDT 2.0 में था, ये जीरो आ गया. So this is something which happened. तो मैं बाकी डिटेल आप दोबारा बार-बार I will not repeat it. So this zero has occurred. Look at my cursor movement, zero has packet zero. So एक बिट सीक्वेंस के लिए चाहिए तो पैकेट जीरो होगा या पैकेट वन होगा, ठीक है? 0 1 0 0 1 0 1 0 1 0 1 इस तरह मूव होगा. Then it will go to wait for call और NAC. अब पैकेट जीरो भेजा तो किसकी एक या NAC आएगी? जीरो की आएगी. सो एक और NAC जीरो, एक जीरो और NAC जीरो, राइट? सो इधर जंप कर जाएगा. Then let's say that packet is received and it is not corrupt and ACK is received. So no action, but it will now wait for call one from above. अब जीरो क्योंकि पैकेट वो भेज चुका था, अब आपके पैकेट वन, अब जो भी पैकेट आएगा अबव से उसको वो पैकेट वन कंसिडर करेगा, राइट? So look at this, RDT send data, now packet one is generated. Look at sequence number. यहाँ पे sequence number देखें, ये देखें पैकेट वन. अब यहाँ पे पैकेट वन आ गया, ठीक है? सो आई होप इट्स नॉट डिफिकल्ट. पैकेट वन अब आ गया और इट हैज गॉन टू वेट फॉर एक और नैक वन. सो सेंटर साइड पे ये जो है वो बेसिकली एक और नैक वन पे जाएगा. ये सेंटर की एफएसएम्स हैं, राइट? एंड लेट्स अज्यूम के रिसीव पैकेट हुआ, इट इज नॉट, so it will move to this, no action will be taken and it will move to call from zero. Okay ji, so these are the sequence of steps which will occur at the sender side for handling garbled acts or NACs. Now if there is a corrupt, now if there is a NAC and that NAC is received, suppose करें अब एक possibility थी कि हमने कहा कि जी look at this now, कि received packet, look at my cursor movement, packet is received, packet is received and this packet is from receiver and is a corrupt. So again it will again send the packet zero again. अगर NAC आती है receiver से against NAC zero आती है तो क्या होगा? ये it will move remain in this state and it will again send the packet zero. ठीक है? Same is the case here. look at the left bottom. Okay, if packet is received, let me wait कि आपको नजर आ जाए. So if packet is received, look at left bottom. Packet is received and it is corrupt. कौन सा packet? Packet 1 is corrupt. So it will again send the packet 1 again. So UTC send packet. Which packet? Packet 1. So this is RDT 2.1. If you have any question, welcome. Have a look on it. So I mean, it's not difficult. Simply you have to, new thing is sequence number, addition of sequence number. New thing is sequence of addition, sequence number. Otherwise RDT 2.1 and 2.0 are same. Sequence number ऐड करने से आपको 2 states extra डालनी पड़ गई हैं. Have a look on it. I'll give you 2 minutes for it, for thinking on it. So if you have any question, you can ask.
सर इस पे तो ये लग रहा है कि पहले एक पैकेट सेंड हुआ, उसके बाद दोबारा पैकेट सेंड हुआ ना, सीक्वेंस नंबर 1 तभी हुआ है.
जी बेटा, कब कहाँ पे हैं आप? मुझे स्टेट बताएं. कौन सी स्टेट की बात कर रहे हैं?
सर वेट फॉर कॉल 1 फ्रॉम अबव.
जी ठीक है. वेट फॉर कॉल फॉर 1 फ्रॉम अबव कब आएगा? ये इधर से आ रहा है ना, एक जीरो नैक जीरो से आ रहा है. एक अगर तो वो एक आएगी, एक जीरो आएगी तब स्टेट में आएगा. ठीक है, एक जीरो का मतलब है पैकेट जीरो की एक्नॉलेजमेंट आएगी तब ये कॉल 1 फ्रॉम अबव में आएगा. वरना दूसरी पॉसिबिलिटी है कि वो इसी में रहेगा. अगर नैक जीरो आती है तो इसी स्टेट में रहेगा और रीसेंड करेगा पैकेट. तो ये वेट फॉर कॉल 1 फ्रॉम अबव से मुराद ये है कि अब जो भी पैकेट अबव से आएगा उसको हम सीक्वेंस नंबर देंगे, वो जीरो की बजाय 1 देंगे. ठीक है, जस्ट फॉर अंडरस्टैंडिंग पर्पस. जीरो से मुराद है कि जो भी पैकेट आ रहा है उसका सीक्वेंस नंबर जीरो होगा. कॉल 1 से मुराद है जो भी पैकेट अब ऊपर से आएगा उसका सीक्वेंस नंबर क्या होगा? 1 होगा. और वो यहाँ पे आप देख रहे हैं, बॉटम में देखें तो पैकेट 1 ही है. ठीक है.
सर इस केस में जो अबव है से मुराद वेट फॉर कॉल फॉर एक्नॉलेज और नैक जीरो, यही है ना?
नहीं, अबव से मुराद यहाँ पे नहीं है. अबव से मुराद वेट फॉर कॉल फ्रॉम अबव से वही मुराद है जो यहाँ पे मौजूद है. कॉल जीरो फ्रॉम अबव है. अबव से मतलब है एप्लीकेशन लेयर से डाटा.
ओके सर.
नहीं, नया का एक जीरो से कोई नहीं मुराद. ये एप्लीकेशन लेयर से है जहाँ पे ये जो चीज है बिल्कुल सेम चीज है. जस्ट सीक्वेंस नंबर ये डिफरेंट होगा. I assume that you have understood it if you don't ask any further question. So now receiver side is your homework. RDT 2.1 receiver side is your homework. Now you can think about it, but I will quickly show the steps without talking much on this slide. So you can just have a look on it. So this will happen. Receiver side. Events, actions. It's not difficult. Look at this. अगर आपको क्वेश्चन पूछना चाहते हैं आप पूछ सकते हैं. I'll reply the question. RDT receive packet not corrupt and has sequence 0. So these are the actions. And it will move to wait for 1 from below. These are the received packet. कौन सा पैकेट 1 मिला से एक 0. Other possibilities. Corrupt. If it is corrupt, it will remain here. NAC भेजने के बाद it will remain here. Another state, sequence number. दिस इज इम्पोर्टेंट, ये जो कर्सर है कि अब उसे गलत सीक्वेंस नंबर मिला है तब भी वो वही करेगा, दोबारा एक भेजेगा। So because it is waiting for 0 here in this case, and the last step waiting for packet 0 from below, but it has received a packet 1. It has received a sequence number with a packet with the sequence number 1. So but it is waiting for a packet 0. So again it will send a ACK and it will remain in this state because it is waiting for packet 0. Okay ji, so this is RDT 2.1, receiver handling garbled ACKs and NACKs. So please study the book chapter. So there is a lot of explanation is given in good English. So I hope then you will be in much better position to understand. So now let's move to the next slide, slide number 19. So because it's a stop and wait. So I already told you it's a stop wait. Reason आपको why की जरूरत नहीं है, answer we have already discussed the answer for it. So we need only one bit, 0 1 will suffice. Then it will must sender will check if received ACK or NACK is corrupted or not. So therefore there will be twice of as many states as in comparison to RDT 2.0. But again you have to keep this thing in mind, sender must remember whether it is expecting packet should have sequence number 0 or 1. Expected packet. So receiver side must check if received packet is duplicate. So it will indicate whether 0 or 1 is expected packet sequence or not. Expected, again the stress is on expected packet. So it will, when we'll get packet 0 and if it is not corrupt, it will move to state with packet 1. Packet 1 means expected packet. It is now expecting packet 1. So this is a summary discussion. Now at the end of today's class, we'll only do one amendment in it. So this is the last topic, only last 2 slides in fact, and this completes RDT 2.0. Now so far in RDT 2.1 we have ACK as well as NACK. Now we can make a protocol without using NAC or NAC free protocol, and we are calling this as RDT 2.2. So you may be wondering, okay, how we can do that? Okay, how we can get rid of NAC? So I mean the functionality, let me tell you, we will be not using NAC. Now we will, in fact, we will be using X to in place of NACs to indicate NAC behavior. X will be used to replicate or indicate NAC behavior. How we'll do that? I'll explain it to you. But again, there will be no NAC in RDT 2.2, NAC free protocol. So its functionality is same, exactly same as of RDT 2.1. There is nothing new in it, but the only one change is that it is a NAC free protocol. Now, whenever basically now what, how it will handle NACs behavior. So instead of NAC, receiver will send the last packet received OK. Receiver will send ACK for last packet received OK. अगर because there is no NAC, तो अगर पैकेट करप्ट होता है, अगर पैकेट करप्ट होता है तो रिसीवर जो है वो क्या करेगा, वो ACK भेजेगा जो उसने लास्ट रिसीव्ड पैकेट, जो लास्ट रिसीव्ड ओके पैकेट की ACK दोबारा भेजेगा. Now you have to understand this, कि receiver will send the ACK of the last OK received packet again because there is no NAC. So if packet is corrupt, receiver will send the last OK received packet acknowledgement again. So therefore receiver must explicitly include sequence of a packet number being ACKed. So naturally, because the receiver is sending the last ACK again, so there will be a duplicate ACK at the sender. There will be a duplicate ACK at the sender. So whenever this duplicate ACK at the sender will result in the same action as of NAC, it will retransmit the current packet. Whenever sender receives a duplicate ACK, it will retransmit the current packet. So how we got NAC free protocol? We are using a duplicate ACK. So whenever sender gets a duplicate ACK, it will assume the packet is being corrupted, so it will retransmit the current packet. So this is how we get a NAC free protocol, and we are calling it as RDT 2.2. So we'll study TCP inshallah after this topic, and there you will see that TCP uses NAC free approach. So have a look on RDT 2.2, compare it with 2.1. If you have any question, you are welcome. Okay, ji. Any question? If you don't have any question, I will stop here. But before this, look at this RDT 2.2 working. This is a sender FSMM fragment. So look at this, red color. Look at the red color. They can wait for ACK 0. It is waiting for ACK 0. Wait for a call from above, and waiting is for a ACK 0. So RDT रिसीवर साइड से रिसीव पैकेट हुआ, वो करप्ट था, ठीक है, सेंडर करप्ट पैकेट था, ये ब्रैकेट में लिखा है assume कि वो करप्ट पैकेट था, रिसीव हुआ, एंड इट इज ACK रिसीव पैकेट 1. अब इट इज वेटिंग फॉर ए पैकेट 0. ACK 0 का मतलब है इट इज वेटिंग फॉर ए पैकेट 0, और उसे ACK क्या मिल रही है? 1. ACK 1 मिल रही है, तो व्हाट विल डू? इट विल रीसेंड द पैकेट. इट विल रीसेंड द पैकेट अगेन. इट विल रीसेंड द पैकेट अगेन. कब ये नेक्स्ट स्टेट में जाएगा? जब उसे ACK 0 मिलेगी. ये लुक एट दिस बॉटम रेड कलर. जब उसे ACK 0 मिलेगी तो इट विल गो टू द नेक्स्ट स्टेट, राइट? Same is the case for receiver fragment. Look at the red light, sorry, red color. So call 0 has received अब it is 1 packet. अब इसे जो acknowledgement मिली है वो 1 की मिली है, तो it will send the packet again. So this is a receiver FSMM fragment. So by this we conclude today's lecture, and inshallah next time when we'll come back, we'll study RDT 3.0. So I would suggest you, all of you, to basically thoroughly study this, because these things, these RDTs, various versions are highly related to each other. These are highly related to each other. So therefore you need to be, study with the from the book. And one more thing I would like to share is this problem set for this chapter in advance, so that you can start working on it. So let me share the problem set. This is a problem set for chapter 3. So please note down these questions or take a snapshot of it, whatever you like. And so there are some topics which we are going to study. So you can start working on it, on those problem sets which we have already done, the topics, corresponding topics which we have already completed. So there are 50 problems in this chapter, so I'm only giving you less than 20. Okay, Ji, is it okay to everyone? So by this we complete today's lecture. So if you have any question regarding RDT, we have studied RDT2 today. So inshallah, when we'll come back next time, we will be studying RDT3. We will be completing this section and we will be starting TCP. Anyone want to ask any question? Welcome.
No, sir.